One of the most important things in AI has been the MCP protocol, but 6 months later, it has become a huge problem for us. When we started, people only had 2 to 3 MCP servers running locally, but MCP has evolved into so much more. Now people literally have hundreds of MCP servers with thousands of tools at a time, and it has become a huge problem. As you know, Cloudflare noticed this first, and Claude followed along by posting a research paper about this problem. But Docker actually came up with a solution for this and solved one of the most critical problems for MCPs by coming up with an entirely new way to use them. A dynamic mode which allows you to save so many tokens, speed up your agents, and make entirely new sorts of automations that I personally am really looking forward to. So Docker actually released an article on this in which they basically urge us to stop hard coding our agents environment. Now, what do they mean by that? First of all, which MCP servers do we actually trust? The second one is, how do we avoid filling our context with tool definitions that we might not even use? For example, if you have 1,000 tools, you might only use 2 or 3 in a single chat. The third one is, how do agents discover, configure, and then use these tools efficiently and autonomously? But I want you to focus on the second one, which is, how do we avoid filling our context with tool definitions that we might not even use? For example, if you have 1,000 tools, you might only use 2 or 3 in a single chat. Anthropic also released a post about this, which we covered in one of our previous videos, and we got a really positive response from people who wanted the implementation. And Docker actually went ahead and implemented this. Now, before we move further, you need to know that Docker actually set up the whole infrastructure for this way before it even became a problem. And for that, you need to know about their MCP catalog, in which they've listed verified MCP servers that you can actually trust. And it's really easy to connect to. You just connect them here in Docker. For example, I've connected Notion here. You can see that right now I have 2 servers, and my MCP client, which most of the time is Claude Code, only connects to Docker, and then Docker basically manages all my MCP servers. So this entirely solves the first problem about which MCP servers we actually trust. Now, to actually enable our agents to use these MCPs dynamically, they've implemented this MCP gateway that already has pre-built tools to use the MCP servers inside the catalog and use them autonomously. So essentially what happens is you only connect one MCP, and this MCP has all the context of which tools it's connected to in the catalog. I've been connected to 2, and it knows which tool definitions to actually bring into the context window, so your context window does not get bloated. Now, for this to actually work, they added some new tools which include MCP find, add, and remove, which basically find MCP servers in the catalog by name or description, and as I'll show you, guide you through how to add them correctly. So for example, I'm using my GitHub MCP right here, and I'm telling it that I want to search for some interesting repos. After specifying what kind of repos, it doesn't actually call the tool itself, but rather uses the Docker MCP server, which then calls the tool with the correct information and obviously returns all the results. Now, I want you to notice one thing. The LLM is returning everything about the repos. It's returning the link, it's returning the stars, it's returning the description, and it even knows the date on which these repos were posted. I just want you to remember this because it's going to be an important thing moving forward. Now, moving on to dynamic tool selection. This is the most important part of the article, and this is what I was talking about when I mentioned a new way of using MCP servers. Again, referencing the Claude article, they talk about how Claude or any AI agent actually uses more tokens. One is the tool definitions in the context window, and the second is the intermediate tool results. This is where we talk about the raw results that are actually returned from MCP tool calls. So all of this detail that we searched using the GitHub tool was returned into the context window. That's why Claude knows every small detail about the repos, while I only wanted the description and the link of the repo. In this way, it only takes a few tool calls, like in my case, maybe it was 20 tool calls before the whole context window is actually filled. This is one thing they've improved in the MCP Gateway project, where they only give the tools that are actually useful. So for example, in my case, one way that the context could be saved is to only give me the search repo tool and not the other 40 tools that come inside this GitHub MCP, because in this session, I only want to use the search repo tool. But again, once you do start selecting tools this way, it also opens up a new range of possibilities, and that leads us into code mode. Cloudflare basically outlined how we've been using MCP wrong and that this is not the actual way. And this is where Docker is actually the first one to implement this new solution. I've played around with it a lot, and I must say I'm really surprised by how the execution turned out. So they say that by making it possible for agents to code directly by using MCP tools, meaning they take the tools and implement them in code, they can provide the agents with these code mode tools that use the tools in a completely new way. So what does code mode do? It creates a JavaScript-enabled tool that can call other MCP tools. This might seem really simple, but the examples I'm going to show you will hopefully clear this up. Now, before we dive into an implementation, there are other things to consider. First of all, since this is code written by an agent, obviously it's not tested and not secure. So Docker has planned for this to actually run in a sandbox. And since they already provide Docker containers, this was pretty much a no-brainer for them. This approach ends up offering three key benefits. First of all, it's completely secure because that's the main benefit of sandboxing. It doesn't do any actual damage to your system. Then there's all the token and tool efficiency that we've been talking about, where the tool it uses does not have to be sent to the model on every request. The model just needs to know about one new code mode tool. So without code mode, if you're only using, let's say, these three tools and it's running these repeatedly, the context of those 47 other tools is also going alongside the three tools that we're actually using. But with code mode, what happens is the agent writes the custom analyze my repos tool using only the tools that we actually need to use. And every time it just references that one code mode tool. And in this way, it saves all that other context by not sending the tools that we don't actually need to use. And then we have state persistence as well, in which the volumes manage how the data is saved between these tool calls, and they're not actually sent to the model. A very simple example of this can be a data processing pipeline. So let's just say that we want to download a dataset. The dataset is downloaded and returned, but it's actually saved to the volume, and the model only gets to know that it was downloaded successfully. The model doesn't get flooded with 5 gigabytes of data. Then if we want to process the first 10,000 rows, the model can just read from the volume where the data is stored and return the actual summary. In this way, only the data that should go to the model, such as final results, summaries, any error messages, or answers to questions, is transferred to the model, and the context window remains clean. Now, the reason I was searching these GitHub repositories is so that I can discover new open source tools to actually put into my videos. And what I normally do is run multiple calls using the Find GitHub repo tool. I just write different keywords to search for tools. So I presented this to Claude Code, and it combined all those different tool calls into a single tool that searches repos based on whatever keywords I give it. You can see that even here, without code mode, Docker actually runs multiple queries, and that's what I wanted to fix. The tool it made was called multi-search repos. And after creating the tool, it used the MCP exec tool to actually run it. It basically gave me 29 unique repos by searching with 6 different keywords. But the results were just returned directly in the response and in the terminal, meaning that all of the results were being returned inside the context window. To fix this, I told it that it should write everything to a file, and the model should just get the description of the repos. No need to give any stars or anything else for that matter. And it changed the tool and wrote all of those results to a text file in my repository, so that if I wanted to look up something specific about one repository, I could do so by referencing the text file. Now, there is one thing that I'd like to see implemented, a way to save and reuse this tool. Right now, the only option is to manually save it as a file. After that, I asked it to search for the Notion MCP. Once connected, I asked if it could make a tool that outputs the GitHub search results directly into Notion instead of using a text file. And again, using code mode, it actually made the GitHub to Notion tool that would allow me to paste the results into Notion. And after it ran that, there were basically some little problems that I had to fix. But essentially, I now have this database in Notion. It's basically hard-coded. So whatever query I provide, it'll just go ahead and input the results into this database according to the different fields. And it'll even include the date so that I can filter through them easily and only search for the results that I actually want. The model only gets to know the name and the description of the GitHub repository it gets at a time. It doesn't get anything nothing else, but the rest of the information is all saved here. Honestly, if you just go through this catalog, you'll get at least a single idea of the MCPs that you could chain together to make these amazing workflows. And at the same time, you're saving tokens and preserving the performance of your own AI agent. Getting started with them is honestly pretty easy. You do need to update your Docker version, but if you still don't have it, they might be disabled in beta features. So do make sure that this Docker MCP toolkit is enabled. Other than that, you'll have your catalog, and these new features are enabled by default. So all you have to do is connect your client and you can pretty much start with them. That brings us to the end of this video. If you'd like to support the channel and help us keep making videos like this, you can do so by using the super thanks button below. As always, thank you for watching, and I'll see you in the next one.